10-3, solving radical equations. That's right, guys. All I am is a teacher who plays guitar. It's so cliche. All right, solving radical equations. Guess what? These are equations that have radicals. And the essential question is, what is an extraneous solution? That's weird. That's a long word there. Extraneous solution. So, I have no idea what that is. You're gonna have to tell me. No, I'm just joking. This is actually kind of interesting, this section, because you've learned about the properties of equality, right? The addition and the subtraction and the multiplication and the division. Well, today it's almost like you're learning a new property of equality, one that you never even knew existed. A radical equation is an equation that contains a radical. Well, that blows me away. With a variable in the radicand. Mr. Plunkett, I don't know what the radicand is. It's the thing that's underneath the radical. So like underneath the radical, here's x. So x is in the radicand. To solve a radical equation involving a square root. Oh no, there's a square root in this equation. It's an equation with a radical. First, use properties of equality to isolate the radical on one side of the equation. So you want that radical by itself. So you see how there's the plus 5 here? No, you don't want that plus 5. So you're going to want to use the subtraction property of equality so that the radical x is by itself. Then use the following property to eliminate the radical and solve for the variable. What is this mysterious property? Squaring each side of an equation. What? You can do that? If two expressions are equal, then their squares are also equal. So if A is equal to B, A and B, they're the same exact thing. If you square A, then you'll have to also square B. Hopefully that makes intuitive sense to you. Like for instance, if I say something really crazy like 3 equals 3, if I decide to square each side, do I still have equality? Is 9 equal to 9? Well, look at there. It looks like it's still A. Okay, we're going to get back down to this careful business in a minute. First, let's just follow the directions we just saw. So solve each equation. We have a radical and an x, a variable inside the radicand. What we need to do is isolate that. How do we do that? We subtract 5 from both sides. Look at this beautiful work. Mr. Plunkett, your work is very mediocre. Okay, so now I get the square root of x is equal to 13 minus 5 is 8. Okay, excellent. Now, if a is equal to b, a squared is equal to b squared. If I square a radical, what happens? Like, how about this? If I square the square root of 9, if I square that, isn't that the same as 3 squared? And what is that? Oh, it's, oh wait, what the? Hold on, let me fix that real fast. Isn't that just 9? So when you square a square root, you just get what's in the radicand. Perfect. So we're going to use this property where we square both sides. As you can see, my work is just looking so good. If I square that, I get x equals 64. Cool. That looks amazing. It looks like we're done. But we may not be. And that's why we have to get to this careful business, because we did something kind of weird. We squared each side of an equation. And when we do that, something can happen. When you square each side of an equation, you're performing what's called a non-invertible operation. So you can get extraneous solutions. That's the essential question. Which are solutions, in quotes, which don't actually make the original equation true. What? How can that be? How can that be, Captain? Well, look at this. If x is equal to 5, and I square both sides, I get x squared equals 25, right? So far, so good? What two numbers can you square to get 25? What two different numbers could I substitute in for x? Well, both 5 and negative 5. So x must equal 5, and x must equal negative 5. Because quantity 5 squared is 25, and quantity negative 5 squared is also 25. But if you substitute -5 in the original equation, which was x equals 5, don't you know, you get -5 equals 5, which isn't true. Whoa! While x equals 5 is true, x equals -5 isn't true. That solution, in quotes, which isn't true, is an extraneous solution. So look at this like really important sentence right here. Check for blank solutions whenever you square both sides of an equation. Extraneous. Extraneous. I gave myself plenty of room here, huh? Okay, so did we end up having to square both sides of this equation? Yes. So I need to check if 64 actually makes this original equation true. So I'm going to do that. Square root of 64, plus 5 equals 13. Is this true? Well, when I take the square root, I take the principal square root, which is only the positive one. So that's 8 plus 5. Is that equal to 13? Ding, ding, ding. Wait, I put 12. Hold on. I was too busy doing my ding, ding, ding. So yes, it looks like 64 is a solution. Huh, so that one didn't have any extraneous solutions. We're gonna have to look for when these extraneous solutions, patterns, when they actually may occur. Okay, well anyways, let's do this. 3 minus square root of x is equal to 0. According to the directions here, we need the radical by itself. I'm gonna add the square root of x to both sides. Mr. Plunkett, that's genius. That is absolutely genius. I know. Guys, I can't help it. Look, it's so genius I gave myself no room. Okay, I'm going to save myself some room here. That leaves us with 3 is equal to the square root of x. Oh no, I don't know what to do, Mr. Plunkett. I've got x inside a square root. Never fear. You can square both sides. Square root of x squared, that's equal to x, and 3 squared is equal to 9. I'm going to substitute 9 in for x. Square root of 9, principal square root is 3. 3 minus 3 is 0. It looks like this is indeed a solution. So that ends part 1 of 10-3 solving radical equations. I'll see you in a second for part 2.